The factorization method is the most common way of solving a quadratic equation, but not all equations can be solved this way. This is when we can use another method called completing the square. The main focus of this method is the coefficient of x, which is b in this case. Divide b by 2 and square it. Then add the result to this. And just like that, this is equal to x plus b over 2 all squared. Yeah, this looks like magic at first. So let's break it down step by step. The first step is to split bx in 2. These two have x in common, and these two have b over 2 in common. So this is x plus b over 2 multiplied by itself. In other words, x plus b over 2 all squared. As simple as that. To put it in another perspective, these shapes are rearranged so that we can add one more square to complete the overall square. And that little square is always a constant number. Okay, now that we know what the completing the square method is, let's take some examples. Start by adding 1 to both sides, then complete the square. The coefficient of x is 1, and half of 1 is 1/2. So add the square of 1/2 to both sides. This can be written as x plus half all squared. And 1 plus any fraction is the same as the denominator plus the numerator of the fraction all over the same denominator. Now this is where things get a bit tricky. Of course, to get rid of the exponent, square root both sides, but always add the plus or minus sign before the square root sign. This is because the square root of a number could either be positive or negative. The square root of 4 is 2, but 5 does not have a rational square root. Subtract 1 over 2 from both sides, and these are the approximate values of x. As you can see, the square root at this side is positive, but the square root at this side is negative. If the coefficient of x squared is not 1, then make it 1. In this case, divide both sides by 2. The coefficient of x is minus 1 over 2. So add the square of minus 1 over 4 to both sides. Minus 1 over 4 squared is 1 over 16. Find the square root of both sides. The square root of 16 is 4. So the square root of 65 is either positive or negative. Therefore, x is approximately equal to these. When the quadratic equation cannot be factorized, then the values of x are always irrational. For the final example, let's take a quadratic equation that can actually be factorized. Divide both sides by 6 and complete the square. The square of 13 over 12 is 169 over 144. The square root of this number is either 5 over 12 or minus 5 over 12. So the answers are minus 2 over 3 or minus 3 over 2, which are rational numbers. So yeah, that is what the completing the square method is all about.